Is this thing on? Hi, I am now reporting live from a scene where it is absolute chaos here. In fact, we are looking at what looks to me to be absolutely no science here. And oh my gosh! It looks like right is now left, left is now right, up is now down, down is now up. I can't really put into words exactly what I'm seeing here, but it's utterly amazing, folks. And now we'll take it back to you in the studio.
Tell Keita he's on in 15 seconds.
Simple, yet satisfying. Come on, guys, no more spit wipes on the set.
Baby! Ready on the...
All right, here we go.
Fire on the set! Fire in the jar!
It's showtime.
Get ready to jam, man. Let's get ready to jam!
Hello and welcome to Headjam. Today on the Jam, it's the big world of science. We're going to take a look at the many ways that science plays a part in your life. Almost everything you do, see, or touch has some aspect of science somewhere in its past. Take this 2-liter bottle of root beer. Over 100 years ago, food chemists began experimenting with the flavor, but the formula has been developing and changing ever since. And the bottle itself? Well, science has had its hand in it in several different ways. Back in the day, it was the glass bottle, to the tin can, even to aluminum, all products of science. And nowadays, we have plastic bottles that have been designed and engineered airtight to hold in all of those wonderful bubbles that make you burp. This is just one way that science works to make our lives so much better. From the foods we eat, to our houses, even to the clothes we wear. Applications of science are everywhere. That's right, it's all about applied science. That's when science moves into the real world to solve real problems.
It's a conspiracy. There are people, they're out there, and they can find me. They know how. They can tell if I've been around. You see, they've got the technology. It's something called forensic science. Whoa! They can take even the smallest little tiny teensy speck of dust and they can match it to stuff that you've left lying around the house. They can test hair, fibers, paint, and my personal favorites, blood. Blood. You see, they put them together and they see what matches and what's similar and what fits. They can tell if you are really you by your DNA. Anyway, that's how I know they're out there. And that's how they know I've been around. Yes. Hey! Oh.
Crime scene evidence comes in all shapes and sizes. Forensic scientists at the Federal Bureau of Investigation perform more than 1 million investigations a year. The goal is to recreate a picture of what really happened. Think of it as a puzzle with some of the pieces missing. Forensic scientists use their knowledge of science to complete the puzzle.
Every case that we have, the question is, could this have happened and can we show that it could have happened? So really we're kind of a fact-finding mission every time we do a case.
The process begins in the scraping room, a room that's thoroughly cleaned before and after each use. It's critical to keep the evidence from being contaminated.
We want to make sure that there's nothing in there that we're going to introduce to the evidence. We want to make sure when we take that evidence out, what's on the evidence is what we're going to find and nothing else. What we're looking for are hairs and fibers. We have actually other people who may look in the same debris that we have for soil or glass or paint chips or any other residue. So really, anything that's on that clothing is probably going to get looked at by somebody. Okay, the way we do a hair comparison is using a comparison microscope. And this is just 2 microscopes joined by an optical bridge. So it lets me look in one set of eyepieces and see 2 hairs side by side. Because we have it in a mounting medium which allows us to see the internal characteristics, it's those characteristics I'm using to do the comparison.
Forensic scientists at the FBI use a wide variety of scientific tests as they examine evidence.
Paint chips come in on victims' clothing in pedestrian hit and runs, or the paint chips may come in from a medical examiner at autopsy. Sometimes we're able to come up with makes, models, and years of one particular color. Other times it could be this particular color from this auto manufacturer or this color from this auto manufacturer.
One scientific process that has become essential in criminal investigations is DNA typing. Investigators can now prove if a suspect is connected to a crime scene.
In order for us to carry out comparisons between crime scene evidence and individuals, we only need to look at a very small part of that. Postage stamps, cigarette butts, envelope flaps that are licked, just about anything that contains biological material is fair game for forensic biological DNA analysis.
When we find one that we consider a single stain coming from a single event, then we'll circle that, test it to see if it's a biological fluid. And in this case, we're looking for blood.
DNA typing is an extraordinarily valuable tool. And you hope that forensic science puts enough pieces of that puzzle in that even though some may be missing, the jury can still tell what that picture represents.
Well, miss, you need a job, and I'm the fella to find it for you. So tell me, miss, is it Skyinki?
Science?
Science. Oh, so just a whole lot of those suckers are silent there. Miss Science, why don't you tell me about yourself so that I can find you that job?
Sure. Well, I have a lot of experience in problem solving. Many successes, a couple little failures.
Failures?
Learning experiences.
Oh, okay.
I have lots of new ideas, sir.
Okay, yeah, shush. Before you just prattle on, how about we take a look at the resume? I think that can give us something concrete and valid and large. This is a little big for what we call a resume. I think we need to work on what people might call a cover letter.
This is the cover letter. Can we bring in the resume?
That's not a resume, that's a rainforest. How about we do what we call editing? We hone down the pages, maybe take one.
You want me to take out penicillin, atomic energy, what?
How about, oh, there's the migraine. How about we just start with your most recent accomplishments, okay?
Well, I'm very proud of what's been going on with the Human Genome Project, exploration of Mars, artificial intelligence. I like to see myself as a problem solver, really. It's a cycle. Question, answer, new question, new answer, new question.
I was looking for something a little bit more concrete, something that we could actually use to get you a job. But since you have absolutely no qualifications whatsoever, how about we find you something at the mall? It's called the science of the hot dog with the corn surrounding it. Capiche?
Weather is critical information, whether you're deciding whether to wear a short sleeve shirt or a long sleeve shirt to school, or whether you're deciding whether you're going to need to take shelter from a tornado or a hurricane or a winter storm. So weather affects everybody's lives.
Here at the National Severe Storms Lab, we study all kinds of severe and hazardous weather, including snow and bigger thunderstorm complexes that might rumble across the plains all night long, you name it.
Scientists like Daphne are working to better understand the Earth's complex weather and storms, especially tornadoes.
We know a lot about the kinds of storms that tornadoes come from, and we're pretty good at forecasting that kind of storm. But those storms don't always make tornadoes. In fact, very few are the really bad ones that you hear about. I've always loved science, and I've been involved in some of our field work where we've gone out with instrumentation and driven right up around the vicinity of a tornado, for example, and you're looking at the storm because it's right there, and it's sort of like hunting in a way. You don't really know what's going to happen when you leave home, then you take your chance on whether or not it does. It may not seem like much, but the distance between the bottom and the top of the storm can be as many as 11 miles or more. Okay, so we're talking the top of the storm might be 50 or 60,000 feet. If you look at that on the Earth, that doesn't seem very far. With the atmosphere, that is a big, big difference. That's why storm spotters are still important.
We like to think of the National Weather Service as where weather begins. The weather information, whether it's surface observations or radar or forecast, begins in your local National Weather Service forecast office. We hope that research, new radar technology, new training with forecasters, increased spotter networks will help us detect those storms and issue better warnings. changes.
In terms of severe weather, we still don't fully understand how and why hail forms. We still don't understand all the processes involved in rain and rainfall and how much rain you'll get from one storm or another storm. That sounds really fundamental, but it's true that we still don't have some very fundamental pieces of what's going on with the weather.
Meteorology is, first of all, an inexact science. We're not able to forecast with 100% accuracy what the weather is going to be. And so it really doesn't matter what TV station you're watching, whether it's a cable channel or your favorite TV weather person, they're getting their information from the National Weather Service. Now, what they do with that information when they get it is up to them.
Weather is not the only way science protects society from Mother Nature. Scientists around the Earth are working to develop better ways to warn us about natural events. South American scientists are studying volcano activity in Chile.
Esto entonces provoca una necesidad.
Man no longer studies the volcanoes out of pure scientific interest, but because he wants to know what it's going to do and how it's going to affect him.
Debe conocer su comportamiento.
In order to monitor volcanoes' behavior, the volcano will exhibit certain symptoms of what it's going to do in the immediate future. For example, a volcano may increase its seismic activity, or it may change its composition of the gas it emits, or the volcano itself may swell physically. One of the techniques which has proven most reliable in recent years has been the measurement of seismic activity. For this reason, we place seismic monitoring stations with seismometers in the volcanoes, and these stations send a signal via radio. The signal is sent to a station where it can be logged on a computer. When there's a sudden change in number or type of seismic event, this alerts us to a possible seismic problem.
Scientists have created a traffic light system to warn about potential volcanic activity.
So the observatory is not only a place where we carry out scientific study, but we also contribute to the safety of people who live nearby.
I think worms are just cool. I mean, they just really are cool. Because worms are creatures that we see out there, but we don't really know a lot about them.
There's more to earthworms than going fishing. These worms are solving a problem by turning food waste into rich compost that will help grow more food.
We actually start the process in the kitchens. Before we start our food waste program, all of these types of materials were going either in the trash or down the drain. And these materials that you see are basically just part of the kitchen prep waste when they're preparing the meals for the day. Somebody had scrambled eggs for breakfast. Got some cucumbers here too. The bananas, and they are the favorite of the worms. Worms actually kind of slurp the food up, so it's real important that we grind the food. We have a grinder. It's not always clean work because grinding up food can get a little messy sometimes. Well, this is a 6 by 8 foot worm bin. It's a industrial-sized container that actually houses about 50,000 worms. We use red worms in this worm system. Red worms are the typical worm you might find if you turned over your leaf pile or to kick over a manure pile in a farmer's field. Sometimes people think I have night crawlers, but the big old juicy worms, but night crawlers actually live too deep into the earth to be the right kind of worm for this type of system. Put some food waste into it along with some of the newspaper that you see, because the food waste in combination with the paper creates the perfect environment for them to be able to live and breed. So as they would eat the food and process the food, they would just work their way to the surface to continue with their feeding frenzy. And the bottom part of it then is actually finished product. The worms themselves aren't the only ones breaking down this food. Of course, there's other microbes and living organisms within the worm bin that help break the food down before the worms actually can get to it. So it is really quite interesting. If you were to grab a handful of compost and throw it under a microscope, you'd see a lot of living creatures there. They're just a natural part of dirt and, organisms that work together.
Hello, I'm back with more that you need to know, because believe it or not, children, there are people who want to know everything about you and everything about me, little old me. But I don't like the man looking over my shoulder. I am the man. So I shred everything. That's right. Every piece of information I've ever had, shred it all right here so that nobody can see it. Of course, sometimes the shredder's just not enough. That's why I go to the next level. Worm-o-matic! That's right. This ain't no namby-pamby shredder, people. It's science! Although, even though the scientists who use real worms have got something going, I have the secret weapon. Sour gummy worms. Oh, the sugar really breaks everything up. See, I told you there wasn't a chicken in there. And at the same time, when I'm done, I've got a nice little garnish for my veggie garden. Now, come on, where's the burger here?
All right, drivers on the line. Human players on the mats. And 3, 2, 1, go!
The battle is on. Robots and high school students in a national competition all about science and technology.
We've just built it over last year, and it's been a continual process, basically.
We were picking up boxes this size. This is actually a type of box. And we're picking them up and stacking them in a zone.
Basically, you tried to knock boxes into your zone, but it turned out the main strategy was just knock everything over. There wasn't really much stacking involved.
It's pushing the entire stack over onto the blue side.
I think it's a combination of engineering, a little bit of science, and technology. It's basically engineering because we had to fiddle with a lot of things.
You had to learn about basic pneumatics to make the arms move in and out and up and down, right?
And also we got to use a lot of technology with wiring the brain, doing the program that actually enabled the robot to run.
Although that was technology, it was science in the sense that we had to figure out the turning radius, how much power we could put through.
I'm always afraid they're gonna break it. Well, 50 years ago, people thought of robots in sci-fi movies, kill robots, kill! In the 70s, robots was a dance. It wasn't anything you had. Now it's something that's on TV.
It's really possible that in the future we could actually have robots in houses. They might not be extremely sophisticated.
Like the RoboVac that are just wheeled that do simple tasks.
Definitely not any robotic nannies or anything among that nature because they'd blow up probably.
Nobody 30 years ago would have said that we would have had computers in our houses. But now we do. Everybody has a computer in their house.
Maybe in 10, 20 years, we'll have robots in our backpacks and at home.
I think ultimately we'll end up having them.
Nanotechnology!
Nano. It's a size thing in a whole new world. Think of a guy over 6 feet tall. This fly is 1,000 times smaller. Inside the fly is the nucleus of a cell that's 1,000 times smaller again. Go 1,000 times smaller again and now you're in Nanoland, a place where scientists are developing tools that might change the way we live.
So the idea is, can you take small entities like molecules and use them for individual functions? That function may be as an electronic switch, it may be as a transistor, it may be as a memory element, it may be a machine, it may be a truck, but now you have many of them. You say, well, how much function could a truck have at this small dimension? Well, the truck couldn't carry that much. But if you have a lot of trucks working for you, if you have 10 to the 23rd trucks working for you, you can move a lot of material. So just the sheer number allows you to have tremendous power at your fingertips.
You can build a nanometer scale piece of material to make a better computer, to make a better sort of airplane wing, or you can also build one to make a better type of medical spectroscopy. So the idea is that nano is a tool that we can use and apply it in many, many different areas.
I want to stand here someday, not too many years from us, here and hold a new crystal in my hand, something I can feel and touch. This single crystal will be the best conductor of heat in one direction of anything that's possible in the universe. In addition, it'll be so strong that if you bend it back and forth, it may not be possible to break it. In tension, it will be 100 times stronger than steel, the strongest thing in the universe. Somebody is going to make this. I'm convinced. I do not yet know how, but that's part of the fun of the game. Try to figure it out, find a path.
In 50 years, I think that this whole nano business will be everywhere. It's going to turn into something that's as ubiquitous as plastics. You know, plastics and polymers are everywhere in our life. We don't even think twice about it. It's in our packaging for our cereal, it's in our CD cases, and I think a lot of nanoscopic materials are going to become that way. They're going to give us much better materials and much better technologies, but it's going to be a part of the fabric of our lives, and it's going to be everywhere.
There you have it. Everything we do, see, touch, and feel, it's all there. Science. It's a way of thinking outside the box, asking how and why, and applying our knowledge to making the world a better place. That's what's up, y'all.
Let me say of something! This is going to be delectable. Another cake ruined, but I followed the recipe. Sort of. Oh, what's a man to do? Help!
Don't worry, fair citizens. We're here to help.
That's right. We'll save you from this kitchen disaster. We're the Science Twins.
Brain on!
Twins. Right.
It's a science thing. You know, powers of the universe, hero type stuff.
Never mind that. You're just 3 simple science facts away from cake success.
Egg whites have 2 proteins, which when brought together form a glue, which becomes a stable foam structure.
That's your cake.
That explains a lot.
The heat of the oven warms the air, which expands the batter to make a fluffy cake.
Remember, hot air takes up more space than cold air.
The right time and the right temperature help the proteins coagulate in the oven.
That means they become solid. Now, you do want cake, not pudding, right?
Wow. Thanks, Science Twins. I understand now. But what about my cake?
Thanks to the power of science and the magic of television, we just happen to have this lovely cake.
Farewell, citizen.
Circle snap peeps.
Don't miss the next exciting knowledge adventure with the Science Twins!
Okay, so Miss Science.
Science.
You know, you've done, it says you've done research at universities, corporations, with the government, basically for everyone, everywhere. And so, what problems that I have you solved?
Let's start with the weather. With the research that I've done, we've been able to develop ways to forecast and predict storms much, much earlier in advance, which helps save lives like your own, as well as farmers and...
Weather girl. Huh? Huh?